I introduced the Lagrangian method as a way to solve the utility maximization problem, but really it's a lot more general than that. In general, a Lagrangian always takes the form of something like this. We have some function at the beginning. In this case, I made it of x and y, and that first one is called the objective function, and it's what you're trying to maximize, as I've said before. But it also works just as well for minimization. Okay, why is that the case? Because suppose we wanted to minimize utility. One way we could do that is create a new function that was negative utility and then try to maximize that, because the highest possible value of negative utility would be the lowest possible utility. Okay, so it works either way. And to this, we always add some kind of Lagrange multiplier, and in general, we have a constraint that looks that in a more general form looks like this. And the constraint is basically that g of x and y, so some function of the things you control, x and y, is going to be equal to some value c. Okay, and this can work for like lots of things besides just utility maximization. For example, suppose I'm trying to decide how I want to spend my time studying, for example, and I have some function of, my final grade as the amount of time I allocate. So, suppose I care about my GPA and I can spend time studying in all my different classes, and I have some function that is like, I have 6 classes, for example, so class 1, class 2, class 3, and class 6, and each variable is the amount of time I study for each one of those classes, and that's going to generate for me my final GPA for the semester, okay? And my constraint is that I have 24 hours before the exam, and I need all of the time I spend studying in them to add up to 20 whatever hours. And I could even add another variable in here for sleep, so that I don't actually, and put that in my function here so that sleep affects my GPA. And this is a weird problem that I just made up, but I could use the Lagrangian to solve it. If I actually had a function that told me how spending time studying for different classes gives me a GPA. It's the structure is identical, right? It's like I'm trying to maximize something, in this case my GPA, and if I had no constraints, I would just study for an infinite amount of time and sleep for an infinite amount of time and then get like a perfect 4.0. But I'm constrained. I only have 24 hours. So all of the time I spend studying and sleeping has to add up to 24. Okay? It works the same way. More closer to our econ example, let's think about how you would solve the expenditure minimization problem. Remember, this was a problem where you have a goal of a certain amount of, subject to a utility target. So you have a problem where you want to hit a certain level of utility. Suppose we want utility to be equal to 100, and the amount that you spend achieving that is going to be the price of food times the amount of food you choose to buy times the price of shelter times the amount of shelter. How do we set up the Lagrangian to solve this problem? Well, we think first we need our objective function, and our objective function is the thing we're trying to minimize or maximize. And in this case, we're trying to minimize our expenditure, which is this guy here. So we would actually write that one first. Okay? Then we have a constraint. And remember that we write the constraint as you have some function of your choice variables. It was g of x, y here, and it's equal to some number. Here we see that we have a utility function that we need the utility function to equal 100. So we subtract u, f, and s. Okay? we've done step 1, set up this function correctly. Step 2 would be to take all the partial derivatives correctly. So partial derivative with respect to f, s, and the Lagrange multiplier. We'd set them all equal to 0, and then we would solve the system. So yeah, the step 1 was setting it up, step 2 was taking these derivatives, step 3 was setting them all equal to 0, and step 4 would be solving the system. Again, you can see that this Lagrangian method is bigger than just the utility maximization. Another strength is that it lets you do as many variables as you want. So that graphical thing works pretty well when there's just 2 things you care about, but the Lagrangian is general purpose, and you can do it for hundreds of thousands of variables. You just have hundreds of thousands of first order conditions, which can be a pain to solve. But we'll go through one example later in the semester and show how it can be really powerful for solving that.